here we're going to take a look and see how they came up with an even better estimate as to the distance to the sun. And the way it was done was absolutely ingenious. You must admit, these people were really smart. I don't think there's any way I would have ever figured this out on my own back then if I had lived during that time. But this is how they did it. They used the transit of Venus to figure out the distance to the sun. How in the world did they do that? Well, remember that for almost 2,000 years, Aristarchus is the one who figured out the distance to the sun in a not so accurate manner, and he came up with the idea that it was about 20 times the distance between the Earth and the Moon, and so that made it about 1/20th of the true value. But it gave us an idea. And then it turned out that Godfrey Wendelin, a French, not a French, but a Flemish astronomer, came up with the idea of using a telescope to take the same measurements, and from that we got a much better, more accurate measurement, which now got it to within about half of the true distance, about 45, 50 million miles instead of the 93 million miles. But then, back in 1639, an astronomer from England, Jeremiah Horrocks, figured out that by using the transit of Venus across the disk of the sun, he should be able to figure out the size of the sun or the distance to the sun. And so what that means is, of course, every once in a while, when the moon and when the sun and the earth and Venus are just aligned in the right way, Venus will travel across the disk of the sun. And depending upon where on the earth you are, the Venus will then travel, of course, at a different location across the sun's disk because of your relative angle between where Venus is at, where the earth is at, where the sun is at. So in 1639, Jeremiah Horrocks actually witnessed through a telescope. Of course, he didn't look through the telescope. Bad idea. He allowed the light of the telescope the light of the sun to go through the telescope onto a piece of paper, and he could then see the disk of the sun, and he can then see Venus traveling across the disk. And what he then did was he actually measured the time, how long it took Venus to go across the disk. But that wasn't really important yet at the time, because he was the only one really that then actually took data of that particular transit. He figured out if more than one person did it, and so at least two people did it, or preferably more than two people, living in different places in the earth, or either traveling to those different places in the earth, and then witnessing the transit of Venus from those locations, he would be able to figure out the distance to the sun. So that's what they did. They sent people out to all places around the world, to Tahiti, to South America, Paris, London, wherever they needed to go to get various aspects of that transit of Venus. And so what they would do is they would have a person on the earth right there, another person on the earth right there. They would look at the transit of Venus, and they would measure the time that it took for Venus to travel across the sun. And by knowing the approximate position of where that disk of Venus was, and then measuring the time that it took to go across the sun's disks, they would be able to figure out exactly where the transit occurred on the sun's disk. And they would then be able to figure out the angle between those two locations, simply by doing geometry. And then, of course, they figured out that the angle from the one place on the earth that the observer was, and the other place where the other observer was, if they then took that angle, and that angle would then be subtended between Venus and the earth, that would be the exact same angle from Venus to the sun. And because you can see the line from there going to this transit, and from this line going up to that transit, so they were able to actually, and of course through Venus, they could actually measure these angles, and then they could say that the relative distance right here on the earth, that d1 divided by this distance between the earth and Venus, let's call that big D1, must equal to this distance right here, which is d2, divided by this distance right here, which is big D2. Now, from Kepler's laws, we knew that the distance between Venus to the sun was about 70% the distance from the earth to the sun. That was Kepler's third law. They were able to figure that out. And so all they had to do was measure this angle by measuring the time that it took Venus to traverse across the sun, by doing some geometry, and by knowing the size of a circle, and they could figure out the distance here, d2. They can then figure out what this angle is equal to, and then they could set up this ratio. And that they knew that the relative distance, that d2 to d1 was 0.7 divided by 0.3, So we can also indicate, and now I'm on to the equal, we can say that the ratio, that d2 divided by d1 was equal to about 0.7 divided by 0.3. Now, based upon those measurements, they were actually able to figure out that distance across the disk of the sun. And from that, they were able to actually find the distance d2 and add that to distance d1 and then get the total distance to the sun. So how did they do that? Again, they took this distance right here and they said that the angle, theta, divided by 57.3 was equal to the ratio of d1 divided by big D1 right there, which of course had to be equal to the ratio of D2 divided by big D2. And then by using this equation and realizing the relationship between D1 and D2, they can use some very simple algebra to figure out that angle. And from that very angle, they figured out the distance to the sun. And it turned out by using this technique, they finally realized that the distance to the sun was roughly, and let me see what they came up with. Well, they came up with a distance that was roughly between 90 to 95 million miles, which was very close to the actual distance. Actually, I think they were just a little bit short. I think they were actually closer to 90 million. So I think the rough estimate was that it was about 90 million miles, which was just shy of the actual value of 93 million miles. So they were just within a few million miles, and I can't quite remember what the actual distance was, but it was just shy of the 93 million miles. This method finally got them really close to the actual measurement to the distance of the sun. Of course, once they knew the distance to the sun, by using this angle of parallax, or by using the angle between the Earth and the sun, blocking out a ratio of 101:2, so they had this angle right here. Let me draw it. So this angle right here, this angle had a ratio of 108:1, meaning that the diameter of the sun had to be 1/108 the distance. So once they knew the distance, they knew the diameter, and once they knew the diameter, they realized that the sun has a diameter about 100 times, or slightly over 100 times the diameter of the Earth. So now they finally knew how big the sun was. They knew the sun was over 90 million miles from the Earth, and they knew that the Earth would fit into the sun more than 1,000,000 times. Now they understood how large, how enormously large the sun was, how far it was to the sun, and how big it was relative to the Earth. An enormous discovery. So finally, in the 17th century, people were able to make some measurements that really got them in a good direction into understanding how big the sun was relative to the Earth. And it was an ingenious way. Just imagine, they measured the time that it took for the Venus to go across the disk. From that, they knew exactly from a geometry where that had to occur relative to each other. Then from that, they were able to figure out this angle. And from that angle and the ratios of distances between Venus and the sun and Venus to the Earth, they were able to figure out the distance to the sun. An amazing feat, but that really set us onto the path to understanding our solar system, and from that the rest of the universe. So kudos to whoever figured that out. But Jeremiah Horrocks was one of the main that was very instrumental in figuring out this method and figuring out how far it was to the sun.